First of all, I want to calculate the length of BC from this bit over here. I know from circle theorem that the radius, remember this is the center to the edge, that's the radius. Radius and the tangent, right, this is the tangent, makes 90 degrees. That's from circle theorem. So I know this is a right angle triangle. And I can apply Pythagoras. I can apply Pythagoras to right angle triangles. Right, first of all, let me just quickly draw a sketch of this, show you exactly what I'm doing. I'm going to work at the length of the entire thing from O all the way to B, from here to here. Right, the dimensions are given as 6 centimeters, 8 centimeters. Now, as I said, I can apply Pythagoras because it's a right angle triangle and two sides are given. I'm trying to work at the longer side. So what I do on the calculator, I can press the square root button, and underneath that I can type in 8 squared plus, because I'm trying to find the longer side. If it was one of the shorter sides, I would have had to take away. So to find the longer side, it's plus, and then 6 squared. So if I do that on the calculator now, I get 10. So this is 10 centimeters. So remember, all of this is 10 centimeters, the entire thing. But I'm only after B to C, right? Just this bit over here. Right, I know from here to here, that's the radius, isn't it? That is the radius, that's 6 centimeters. So all I've got to do now is 10 take away 6. Leaves me with 4 centimeters. So this bit over here, B to C, is 4 centimeters. Right, so from B to C is 4 centimeters. From C to D is 6 centimeters. 6 plus 4 is 10. So the answer is 4 centimeters. Right, next thing I want to do, I would like to work out the area of the sector shown in the inside of the circle. Right, what I mean by that, I'll show you. The sector, this is the sector I'm trying to work out, this shaded bit. This is a sector, it's how you'd cut a pizza. Now the trouble with that is that I don't know what this angle is. If I knew what this angle was, let's suppose, okay, let's suppose this angle happens to be 50. Then to work out the area of the sector, all I've got to do is 50 out of 360, because angles around a point, around this point here is 360. So 50 out of 360 multiplied by the formula for area of a circle. The formula for area of a circle is pi r squared. Then I would use that to work out the area of the sector. Remember, that's just a small part, a fraction. That's just a fraction of the full circle. So now I need to do this properly. Yeah, I can't just say it's 50 degrees. So really I need to work at this angle here. Now this being a right, we've already established that this is a right angle triangle. Right, we've got two sides and I want to work out an angle. So that's going to involve trigonometry. So I'll just quickly write SOHCAHTOA. Now I've covered this in a previous video. Right, I need to label the sides. Remember, the longest side here is hypotenuse. Longest side is always opposite the right angle. Right, this is opposite. Because it's opposite the angle that we can use in our calculation. And there's only one word left, adjacent. Now, out of these three words that I've labeled, one of those I don't need. The one I don't need is hypotenuse. Why? Because I'm not after that side. I'm not interested in that side, and there's no number given to me that I can use in my calculation. So I'm only interested in this one here, the opposite, which is 8 centimeters, adjacent at 6 centimeters. Now, I need to find a triangle one of these triangles that has got the word opposite and adjacent. So which triangle has got the word opposite and adjacent is this one here. Opposite, adjacent. So let me just develop that a bit further. That's my opposite, adjacent, and that's T for tan, which you can find on the calculator. That's tan angle. Right, this is the angle. So now I need to substitute the numbers that I have. The numbers that I have, opposite is 8 centimeters. That's 8 centimeters. Adjacent is 6 centimeters. So now I've got to do divide. So tan x is equal to opposite divided by adjacent. 8 divided by 6. So what I need to do now, I need to get the angle. Remember, x is the angle. I need to shift the tan out the way. So press, if you've got a Casio calculator, you can press shift tan, and that will bring this up on the display, shift tan. And it'll come up with brackets. Inside the bracket, you can put 8 over 6, or if you like 8 divided by 6. Remember to close the bracket. I'm going to do that on the calculator. Shift tan, 8 divided by 6. Remember, you don't always have to shift tan or shift cos or shift sin. You only do that when you try to extract the angle, when you're not trying to work at the angle, when you're not trying to work at the angle. So don't use the shift. I get 53.13 degrees. So that their angle x is equal to 53.13 degrees. So I've got my sector now. Right, if I just quickly draw that, which is really a part of a circle. It's got a radius of 6 centimeters. Now the formula to work out, as I've just shown you, this sector over here, which is really a part of a circle, it's 53.13 out of 360. It's just a fraction of a circle of pi r squared, or if you like pi 6 squared, because the radius is 6. So I'm going to do that on my calculator. Use a fraction button. I've decided to use the pi button on my calculator. Right, if I just round it to one decimal place, I'll get 16.7 centimeters squared. That's the area of this sector over here.